Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss a typical question on Young's double slit experiment from Cambridge AS Physics. Part A is simply asking us, we need to state by reference to two waves the principle of superposition. Principle of superposition simply tells us when two waves meet at a point, how we can find the resultant displacement of resultant wave. Let's try to understand this one with this simple example. As you can see here, in this case we have two waves. One wave is blue wave, let's say this is wave B, and we have a green wave, let's say this is wave A. As these two waves meet at this point, if you need to find the resultant displacement of resultant wave of these two waves, simply you need to add the displacement of these waves. But we have to be clear about displacement. Displacement is a vector quantity, so it can be positive, it can be negative. So for this purpose you have to be careful. Let's say the displacement of wave A at this point is dA, and the displacement of wave B, let's say at this point, is dB. If we need to find the displacement of resultant wave, simply we need to add these two, so that will be equal to dr, means the displacement of resultant wave. But if you look at the displacement of these two waves, they have the same displacement and positive, so simply we can say dr is also equal to 2 times of dA, or we can say this is 2 times of dB. Now let's try to understand when these two waves have negative displacements. So if we look at this point, these two waves, they have negative displacements, so we can say the displacement of wave A, this is minus dA, and the displacement of wave B, this is also negative dB. So the resultant displacement of resultant wave, that also will be negative, so this is equal to the sum of these two displacements. So this is displacement of resultant wave. At this point, resultant displacement of resultant wave was this. Let's try to look at one point when one wave has positive displacement and other wave has negative displacement. If we look at this point now, you can see wave B, means the blue wave dB, this has positive displacement, and the green wave, this has negative displacement. So we can say dA1 is positive, dA is negative. But in this case, dB is greater, so the displacement of resultant wave, that will be positive. So this is all about principle of superposition. It's simply you have to add individual displacements to find the resultant displacement. Let me explain to you how to define now. So this is how you can write principle of superposition. Means when two waves meet at a point, resultant displacement is the sum of the individual displacement of each wave. Second part is simply asking us what is meant by coherence. Coherence simply means that constant phase difference. If two waves, they have constant phase difference, we can say those two waves are coherent. Constant phase difference. And also we need to understand constant phase difference is only possible if waves have same frequency. Otherwise, constant phase difference is not possible. So when we say waves are coherent, it means they have the constant phase difference and also they have the same frequency. Let's try to understand what exactly it means by constant phase difference. As you can see here, I have already drawn two waves. Let's say this wave is wave A and this wave is wave B. Now we need to check these waves are coherent or not. For that purpose, we need to check the phase difference. So we can check phase difference at different positions or at different points. If that is the same, it means waves are coherent. If that is not same, it means waves are not coherent. Let's look at wave A at this point. So simply you can see at this given position, these two waves, they're antiphase. So the phase difference is equal to 180 degrees. Now let's check another point now. If we look at this point now, let's say look at this position now. Again you can see these two waves, they have a phase difference that is equal to 180 degrees. This one we can check at any point. If that is constant, then we will say these two waves are coherent. Now if we check at this point and this point, phase difference, again this is equal to 180 degrees. So you can see these two waves, they have a constant phase difference. So it's simply you can say that these two waves are coherent. So this is how you can write your answer. Constant phase difference between the two waves. And constant phase difference is only possible if waves have same frequency. For part B, it is given to us that two coherent waves P and Q, they meet at a point in phase. And amplitude of wave P is given, that is 1.5 centimeters, and its intensity is I. The resultant intensity at the point is given, that is equal to 3 times I. We need to calculate the amplitude of wave Q. First of all, let's try to write down what is given. For this question, it is given to us that amplitude of wave P, this is equal to 1.5 centimeters, and intensity of wave P, this is equal to I. And intensity of resultant wave, let's say, is IR, and this is equal to 3 times I. But by principle of superposition, we also understand that amplitude of resultant wave will be equal to amplitude of wave P plus amplitude of wave Q. So this is what is given to us. Now let's try to understand how we can use the relationship between intensity and amplitude to calculate amplitude of wave Q. We understand for waves, intensity is directly proportional to amplitude square, or we can simply say intensity is equal to some constant times a square, or we can simply write down intensity over amplitude square is equal to K mean is equal to constant. This is very important point we need to understand. It simply tells us for any wave, the intensity, the ratio between intensity and amplitude square is constant. In other words, we can also say that I1 over A1 square, this is equal to I2 over A2 square. Now in this case, our I1 is wave P, so this is amplitude of wave P square, and resultant wave in this case is intensity of resultant wave is IR, and the amplitude of resultant wave, that is AR square. So it means the ratio between intensity and amplitude square is constant for any wave. Mean that is constant for individual wave, and that is also constant for resultant wave. Now in this case, we need to find the amplitude of wave Q. We can a little bit rearrange this one, so we can write down, as we need to find the amplitude of wave Q, we can rearrange this one again. We can say this is AP, AQ square, this is equal to intensity of resultant wave multiply by amplitude of wave P square divided by intensity of wave P. As the amplitude of wave P is given, we can write down its magnitude plus this is amplitude of wave Q. And intensity of resultant wave is given, we can also write down its magnitude. So this is intensity of resultant wave. Amplitude of wave P is given, that is 1.5, and the intensity of wave P is given, that is I. Now simply what we need to do is, if you look at I, you can see in numerator I is here and I is here, we can just cancel out, and remaining what we left is that little bit messy. Let me write down in a clear way. So we left with 1.5 plus AQ square, this is equal to 3 times 1.5 square. Now if we take square root on both sides, we can write down this is 1.5 plus AQ, and this is equal to root of 3 times 1.5. Now if we solve for AQ, we will get AQ is equal to 1.1 centimeters because we are using unit for amplitude centimeters. So our final answer is 1.1 centimeters. So this is how we can answer this type of question. Part C is all about Young's double slit experiment, and for this experiment wavelength of light is given, slit separation is given, that is A, and the distance between screen and double slit is given, that is capital D, and fringe spacing is also given, that is X. So let me explain to you what exactly is fringe spacing. Fringe spacing is the distance between two adjacent bright fringes. In this case, this is X, and X is called fringe spacing. And it is also given to us that as capital D is increasing, X is also increasing. And question is asking us, we need to find the slit separation A. But in this figure, you can see as D is increasing, X is also increasing, mean the spacing between bright fringes means this value of X is also increasing. And question is asking us, we need to find the slit separation. In order to find slit separation, we need to understand the relationship between slit separation, fringe spacing, wavelength of light, and the distance between slit and screen. So this is the relationship. From here, as we need to find A, we can just rearrange this. Now the value of wavelength is already given to us, and that value is 680 nanometers. So we need to multiply with 10 to negative 9. But value of D and X is not given. So we can just pick any point on this line and we can plug in value of X and value of D. But I will take this point because this is more easy to find value at this point, the coordinates of this point. So in this case, the value of X is given. X is 4 millimeters. This is value of X, and we can also find the value of D, that is 2 meters. Now simply we need to solve this one, and if we plug in values in calculator and we solve for A, our final answer will be 3.4 times 10 to negative 4 meters, and this is value of A, and this is constant. For second part, it is given to us that the laser is now replaced by another laser that emits light of a shorter wavelength. It simply means that this laser now we replace with another laser, and the wavelength of new laser, this is shorter than 680 nanometers. But we are using the same double slit, so A is constant, so A is the same. So simply we can say A is constant. And question is asking us to sketch on figure 5.2 a possible line. So how we can answer this question? This is quite straightforward one if we understand Young's double slit experiment. For Young's double slit experiment, the formula, we need to understand the equation for Young's double slit experiment. And we have used that equation in part A as well. So let me rewrite this one so you can get better understanding. So this is what we have used for part 1. Now for this part, it is given to us that A is constant. We are not changing A. We are not changing slit separation, but we have decreased lambda. So if lambda has decreased, it means the ratio between D over X. The ratio between D and X, this has to increase. Or simply we can say that the ratio between X over D, this has to decrease. Or we can simply say the gradient of new line has to be shallow, has to be smaller. So the gradient of new line has to be shallow. So simply we need to draw a line below this line. This is how you can draw the line.